Hi, I'm extreme meteorologist Reed Timmer, and in this video I'm going to share with you the science of Hurricane Ida. We deployed an extensive scientific mission that did include subsonic sensors. That's a microbarometer, the most sensitive barometer to ever be deployed inside of hurricanes. We're trying to track those tornado-like vortices that will whip around inside of the eye wall. Hurricane Ida had at least 4, maybe 5 of these tornado-like whirls. And I'm also going to share with you the surginator data that we collected. These are live streaming sensors that will share storm surge depth based on the pressure weight of that water. They do have a station that fits up above the water level. That makes it possible to live stream life-saving information on storm surges. Here is the subsonic sensor. We deployed 2 of these through Houma, Louisiana. These are very sensitive barometers that are even capable of measuring infrasound waves, basically that heartbeat inside of the hurricane based on asymmetries in the eye wall. And then the surginator probes. This is the head that fits below the water of the surginator, and then it uses the pressure weight of that water to measure very fine scale storm surge depth, even including the very small waves on top of that storm surge. These can also measure the salinity of the water and the temperature of the water, and that information can be used to determine the source. If that storm surge came from the very warm waters of the Gulf of Mexico, if that water gets up to 30 degrees Celsius or warmer, that means that it's definitely from the Gulf of Mexico. And these are the stations that exist well above the water line, and we connect the surginator head with the station with this large waterproof cable, and that information on storm surge depth feeds up to this station, and then it's set up to the website. Live information, real-time information coming in with storm surge depth, and eventually the game plan is to deploy dozens of these sensors out ahead of the hurricane so that we can gain information on the very complex storm surges, especially in southern southeastern Louisiana, where those floodgates and levee systems lead to a very complex storm surge. You can have locations just to the north or the south of a floodgate receiving life-threatening surge, very destructive surge, 10 to 15 feet high, and then the other side, the protected side of the floodgate, can have almost nothing. And so it all depends on the exact track of that hurricane, and it definitely was a very intense ride down as well. We got in to Houma at about 4 in the morning, and the hurricane was already rapidly beginning to intensify, and we had no choice but to head straight down to the bayous of southeastern Louisiana. Thanks to Detective Ryan Troclair that was able to get us down there near Duloc Bayou, Delarge, and down in the Cocodrie area. That's where we're able to deploy those surginators. So in this video, I share with you the journey of deploying those surginators and the data that was collected by those and the subsonic network within Houma that was ravaged by that western eye wall of Category 4 Hurricane Ida. After arriving in the middle of the night in Houma, Louisiana, Hurricane Ida was moving a little bit faster than expected. So we were running out of time, and we had to head south to the bayou to deploy the surginator network before the floodwaters got too high. Yeah, the station at the top. So the surginator's at the bottom. It'll be at the bottom, and then I run that wire all the way up to the station at the top. And that station at the top can't go underwater. Yeah, we need a GPS
Nothing like a good old-fashioned police escort.
Got this cute little collapsible ladder. It's Subaru friendly, but still 17 feet. This is not OSHA approved, is it? Well, you can't.
I know where we can go. Just down to the absolute end of the road. Okay. Which is right there. Yeah, because they're gonna have pylons at the end of the road that'll be a little easier to secure. A little more friction than a metal pole.
want to see a gator.
He thinks it was started by the pressure fall.
Oh, really? Because he was just hanging out?
Yeah.
It's getting strong, Reed. We gotta go. Look, I'm helping. Yeah, I don't know if I'd say it's a good chance, but it's a chance.
Well, the next one then, do you think we should try to go all the way? Yeah. I guess we could go all the way to the research center, but
I think this is as good a spot as any.
the water.
Road. What? The water's come up over the road while we're sitting here. Oh, shit.
Yeah, let's go.
Sounds that way.
Okay.
Let's go. Hey, it's time to go, Reed.
Yeah, I gotta secure this bottom part. Right?
Okay.
That tight. We just need to get over the roads a little higher. How I thought. I don't like to test it now.
Yeah.
But I mean, that came up pretty quick.
Yeah, it did. We haven't been here that long.
No.
I'm scared. I'm scared.
Which that's the east. So it's they're all in easterlies. Easterlies right here. Yeah. Yep. Right here. Good? Yep. Are we getting tied right now or Hey, you guys gotta record the exact GPS and time.
That was the station of the Surginator sensor. That sends a live streamed Surginator depth, the storm surge depth, live up to the Team Dominator website. And that also measures temperature, also high resolution pressure as well, so that we're able to see those gravity waves as they're moving around. And the goal really is to deploy 3 different Surginators so that we could track those gravity waves and those pressure whipsaws and get data of the real-time storm surge as it comes in. Here is a group photo that includes Detective Ryan Troclair there on the right, Connor McRory, the Irishman, Mike Scantlin. This is just right at sunrise after we deployed the first Subsonic Sensor, and here you can see that eye that was coming in quite rapidly there. We were in Houma. This was after we deployed, and that eye came into Chauvin there. The eye wall was absolutely hammering the Subsonic Sensor network as well, and this shows the landfall of Category 4 Hurricane Ida. Coming in right, and notice how the Surginator network sampled a majority of the northerly winds on the west side of the circulation. So at this time, the eye was coming in down there at Golden Meadow, off in Grand Isle. You had the onshore flow down in that location, and that onshore flow caused a mega storm surge to come on shore there. The northerly winds on the west side, our goal when we deployed this Surginator network was to capture the onshore flow, but initially that forecast track was going to be just a little bit further to the west. Initially the forecast track of Hurricane Ida was going to be to the south of the Surginator network, and that would have brought onshore flow onto the 3 stations that were deployed there on the northwest side of Terrebonne Bay. But the hurricane ended up coming right up the heart of the bay, passing just to the east of Terrebonne, or right at the southeastern portion of Terrebonne Bay, just to the east of Cocodrie, Surginator 3, and then Chauvin got in the eye, and then it ended up stalling just to the west of Houma before turning off to the north, and that caused Houma to be in prolonged western eye wall, and that allowed the subsonic sensors to measure those different mesovortices, or those tornado-like whirls, as they passed one after another by the subsonic network. And I'm going to show you that data set after we discuss the Surginator sensor. But if you can imagine a counterclockwise spin to the hurricane inside this bay. The eastern side of the hurricane is where you get the onshore flow. So down near Port Fortune, Grand Isle locations down there had that onshore flow, a double-digit storm surge, but it was a bit more complicated out in this portion of the bayou with that northerly flow as well. And there are some floodgates out there just to the north of where we deployed the Surginator number 3, and that northerly wind on the western side of the circulation picked up water here, Lake Boudreaux The rest of the bayou here as well, that water that was transported inland up toward Golden Meadow and then back around with those easterlies and then back to the south off of Lake Boudreaux ended up piling up on the floodgate just to the north of the Surginator. And we have evidence of double-digit storm surge there, including debris impacting many of those camps in Cocodrie just to the north of that floodgate. Surginator 3 was deployed to the south of this floodgate, so we don't have as much storm surge that was measured just to the south of that, but definitely a very complex environment here with these levees and those floodgates. Some areas will get hammered by a life-threatening destructive surge. Other areas on the sheltered side of those floodgates, not as much, but you definitely had that onshore flow coming onshore here. Grand Isle, Port Fourchon, where 172 mile per hour wind was measured. And then over here, our Surginator network ended up getting the northerly side of that eye wall and absolutely got hammered by destructive winds on the western side of the eye wall. Drone footage that we shot just to the north of that floodgate showed absolutely extensive damage on the north side of that floodgate. And let's zoom in a bit here on the Surginator network. We could zoom in on Surginator 2 and 3. Surginator 2 was also deployed on the south side of that levee. You can see the levee indicated there in the blue and the floodgate as well, right over the road. This is the floodgate in this location. And our goal was to deploy to the south of that floodgate so that we could get the maximum surge off of Terrebonne Bay and the Gulf of Mexico. The Surginator units also measure the salinity and the temperature of the water. That gives us information on the source of that storm surge. So if we see that water temperature rocket into the low 30s degrees Celsius, 31, 32 degrees C, or at least any increase, that means that you're starting to get intrusion from the very warm Gulf of Mexico. But I'm going to show you that Surginator data and how it provides information on the source of that water. But here you can see this levee just to the north of Surginator 2, deployed in Duloc, to the south of Duloc. Then it drops down here. This is a protective levee. And then you have a floodgate over the road there at Cocodrie. The research center, Lumcon Research Center, is down here where Surginator 3 was deployed to the south of that floodgate. The drone footage shows extensive damage. Extensive evidence of double-digit storm surge to the north of that floodgate, and that's with those northerly winds taking that water off of Lake Boudreaux on the western eye wall of this. As major destruction was happening, some of those winds shifted over to the northwest as well, and that piled that water on the north side of the floodgate. To the north of the floodgate, absolute extensive damage caused by storm surge. Then to the south of the floodgate, hardly any damage from storm surge. So it is very likely that that floodgate, which is designed to protect areas to the north from southerly onshore flow, actually ended up protecting the research center to the south of it from those northerly winds, with a slightly unexpected track a little bit to the east as compared to when we deployed the initial Surginator sensor there. So here is some of that damage that was shot just on the north side of that floodgate in Cocodrie. You can see a lot of storm surge damage. You can see a debris line as well along the levee off to the east. There you can see that debris line, extensive debris line along that protective levee off to the east. There you can see the debris piled up against the floodgate. This is the floodgate that I just identified in that levee system just to the north of where the Surginator 3 was deployed. You can see a lot of road damage as well from that surge from the north, a very interesting surge that was piled up against that floodgate just to the north of the Lumcon Research Center. There you can see some of those boats as well that were piled up. Big time debris line, absolutely substantial debris line down in that location as well. And zooming in a bit more, this is in general what happened. There you can see that floodgate extending west to east over the road there, just to the north of the research center. And in general, destructive surge off to the north. Here's the drone footage showing that extensive damage along the road here. Thankfully, a lot of these are fishing camps, but there are a couple of residents that do live down here in Cocodrie. That debris line right here along the levee just on the east side, as those northwesterly winds and that powerful eye wall were piling the debris up along that floodgate and along this levee system. Surginator 2 off to the west was also to the south of that levee system, so it wasn't able to sample this big-time storm surge, but definitely video showed at least a double-digit storm surge to the north of this floodgate, and there are little roads, too, that you could take to get around that floodgate if you're trapped down here and then those floodgates happen to close. But we deployed the Surginator to the south of the floodgate, anticipating southerly flow with a track of Hurricane Ida near or just to the south of the Surginator network, but it ended up taking that turn to the north a little bit earlier, brought the onshore flow near Port Fourchon, Golden Meadow as well, and Grand Isle, and brought that 10 to 15 foot surge up in those locations, causing absolute total destruction. But here on the west, this floodgate caused that storm surge to pile up on its north side. Big time debris, big destruction up there as well. And unfortunately, we didn't have a Surginator that was deployed on the north side of this floodgate, and then we'd be able to compare the storm surge data from just to the south of the floodgate and compare that to the north. We could look at the salinity data and the water temperature data to give us an idea of exactly where the source region was for that storm surge. And here's an even closer zoom in satellite imagery showing you that floodgate. So there you can see that floodgate. Zooming in, you can see that little road that goes around the left side of the floodgate. That's for emergency vehicles only on that left side of the gate. So this is that little road right here. This is the levee system that extends west to east, and that's designed to protect Houma off to the north from a big-time onshore surge that would funnel water up this canal. But instead, with a further east track of the eye of Hurricane Ida, that brought the eye wall and these northwesterly winds picking up water from Lake Boudreaux that also received surge from the east as Hurricane Ida was coming in. All that surge that came on shore near Port Fourchon, Golden Meadow, continued off to the east, circulating counterclockwise, and then those northwesterly winds here causing big damage, a lot of flooding around some of these storage vessels out there as well. And that levee system, which extends off to the east out here as well, all that debris was piled up on this east side of that protection from those northwesterly winds coming in there. This is the image of the eye. This is about as the Surginators were absolutely getting hammered there to the south of Chauvin. Chauvin was in the eye there. Dulac was in the eye wall. The Surginator at Cocodrie was in that inner eye wall with those tornado-like whirls moving past the gravity wave observer network. So here is the data that we collected inside from Surginator 3. Surginator 2 and 4 had some issues with the flash recording devices, so they didn't record very valuable storm surge data, even though they were recording gravity wave data inside. And here you can see the wave action on the Surginator sensors. This is Surginator 3. This is the one that was deployed outside of the research center. Here you can see a storm surge of basically near zero. And then as the hurricane was approaching, look at all this wave action. The storm surge rose up to about a third of a meter, at the maximum height on the closest approach of that hurricane. But that was just to the south of the floodgate. And you saw that video, the drone footage that shows evidence of big-time double-digit surge just to the north of that floodgate. I wish we had another subsonic sensor there to the north. Here you can see the pressure fall dipping below 960 millibars with the closest approach of that eye down there. So the red line, that's measuring pressure. You can see the little gravity waves, the little oscillations there within that high-resolution pressure measurement. I do have evidence of tornado-like mesovortices in the subsonic data. We deployed that network inside Houma, and I'm going to show you that coming up here next. But here you can see this wave action. These Surginator sensors are such high resolution that they're even capable of resolving that wave action inside the storm. And here is the water temperature of the Surginators, hovering at about 25 degrees Celsius. That's bayou freshwater. So that's coming in from the north. You don't have that rise in temperature up near 30 degrees Celsius or even 31 degrees Celsius, which would indicate Gulf of Mexico water intrusion. You do have this late rise in those water temperatures, though. And notice this water rise, a couple holes in the data set there. But for the most part, the live streaming data is showing that water rise well after Ida passed. That's when you finally got those southerly winds. And you started to get that increase in the water temperature, showing that you're starting to get a little bit of Gulf of Mexico intrusion. You can see a bit of a drop of the salinity as well there. Here is temperature, relative humidity, of course, very close to 100% inside the very moist tropical environment of a hurricane. But just fascinating data there, showing that storm surge rise right at the end. Zooming in a bit on this data set, showing you the fine scale oscillations of this surginator data. Let me zoom in here really quick. We're not in studio mode, so you're going to actually watch this zoom happen. And that orange line is the storm surge depth. So there's the orange line. You can see the wave action on top of it as well. All these little fine scale oscillations. That's the wave action being measured by the surginator. The pressure depth there, it increases above a foot toward the tail end of the data set. And that is as those southerly winds on the backside of the hurricane finally brought some surge to the south of the floodgate. But if we had a storm surge sensor on the north side of the floodgate, you'd see this rapid rise, and it wouldn't be associated with a temperature rise because that water is coming off of Lake Boudreaux, areas off to the north, fresh water, which is in the mid to upper 20s in degrees Celsius up there as well. But you can see that wave action. Surginator 3 definitely worked. Surginator 2 and 4 had some issues with the flash drive there on the head of the surginator. We have that fixed now, so those will be definitely included in that data. But that is mainly from northwesterlies. You can see those mesoscale vortices, those tornado-like vortices that are passing through the surginator network as well. Here you can see my attempt to penetrate the eye. So after we deployed the surginator sensors, we drove down in the middle of the night about 3 or 4 in the morning. Thank you to Detective Ryan Troclair for getting us down into the bayou, the deep South Terrebonne Parish, down there to deploy these sensors. This is as we were heading through Chauvin and northern Cocodrie, heading down, approaching that floodgate. After we deployed the surginator network, we then retreated to Houma to deploy the Subsonic network. And that is designed to measure the fine scale pressure oscillations inside of these mesovortices as the hurricanes come ashore. So usually hurricanes will often have 4 to 5 mesovortices that spin around, and you can see these little kinks inside of the radar image. There you can see my location up there in Matthews, just as I was dropping south inside the most intense northern eye wall of Hurricane Ida, eventually intercepting that eye at Lockport, measuring a minimum pressure of about 940 millibars, dipping just below 940 there at a time. This is the min pressure that I sampled with the Radar Omega app there, about 941. Just after that, it dropped below that 940 millibars. And this is the map that shows the locations of the subsonic data. So just after I rocketed off to the northeast to deploy after the eye of this storm, I deployed 2 subsonic sensors inside downtown Houma. One off to the north there, that's Subsonic 3. Subsonic 2 was deployed off to the south, and actually this map is looking off to the south, which is facing up in this screen. So this is Subsonic 2. That location, I deployed it inside the courtyard of a church, and then here is Subsonic 3 off to the north. And since these are such sensitive barometers, even the wind going up and over a building can definitely be registered as a pressure fall. You'll see the compression, the rise in pressure, the approach of that pressure wave, and then you'll see the dramatic fall on its backside. So these are our 2 locations. These are the most sensitive barometers ever deployed inside of hurricanes to try to measure those tornado-like whirls that are spinning around inside. And so with Subsonic 3 being located off to the north of Houma, Subsonic 2 off to the south, when one tornado-like whirl will pass from north to south, it'll actually move over the subsonic first, Subsonic 3, and then we'll see it pass over Subsonic 2 as well. This shows you both data. The orange is the Subsonic 3. That was a subsonic sensor that was deployed off to the north side of Houma, and then about a quarter mile off to the south is where yellow, which is Subsonic 2. And you can see on the approach of the hurricane, the northern or the southern subsonic would register a slightly lower pressure than the northern subsonic, and that's because the hurricane is approaching from the southeast. So with that southeastern approach, that's why you can see the northern portion or the upper portion of the yellow from subsonic 2, which is located on the south side of Houma. Orange is subsonic 3 on the north side, and the opposite is true as the hurricane is moving away. Then you can see that the slightly lower pressure was actually being measured by the northern subsonic or subsonic 3, which is relatively closer to the minimum pressure of the hurricane. And you can see this sharp fall here being indicated by subsonic 3, which is in the north side of Houma, but that was not indicated by subsonic 2. So that's not a pressure whirl that passed over the northern one and then passed over the southern one. That seems to be a really quick gust that only impacted one of the subsonic barometers off to the north. And what I find interesting is you can see this steady decline in the pressure. That is as Hurricane Ida was approaching Houma. It was passing off to the northwest, a very steady trajectory with some wobbles in it, heading straight for our subsonic network in Houma. And then it put on the brakes just to the east of Houma. That prolonged the western eye wall over town, and you can see when it put on the brakes right about here in both subsonic pressure traces, you had this steady linear fall that suddenly stopped right at that location. It leveled off, if not even a rise a little bit, as the hurricane completely stalled out, and then it began its northward turn. And after it began its northward turn, you saw a little bit of an increase. And then the minimum pressure wobbled a little bit closer, reaching basically the minimum pressure of both subsonics, about 950 millibars. This was actually the official low, but that was outside of the pressure minimum, and so that's likely related to more of a wind gust. And what's especially interesting is this wobble that happens while the hurricane is basically near stationary, and that shows you those 4 to 5 tornado-like mesovortices as they're passing one after another, passing over the subsonic sensor or nearby, basically asymmetries in the eye there. And I believe that oscillation being picked up by both subsonics is those mesovortices, basically 4 or 5 of them inside the eye. But not much is known about these mesoscale vortices. There's likely a fractal pattern, likely small scale structure within there as well, likely little eddies from individual wind gusts passing over surface roughness can potentially be coupled with convection, and then they can develop a more substantial tornado-like whirl. But sometimes you just get these whirls caused by surface roughness, big-time wind gusts that will pass over it, and they may not be coupled in a very deep layer. They may not be very long-lived. Sometimes these can even be turbulent eddies like this initial one with this substantial fall. That's a very fine scale pressure fall there. And we also measured temperature with the subsonic. You can see that they were both equal relatively early on in the pattern. And then interestingly, the northern subsonic ran a temperature that was just a little bit cooler than the southern one, and that's likely due to the deployment locations, maybe some small scale meteorology there. Thermodynamics are a little bit more difficult to measure. This subsonic is definitely more focused in on the fine scale oscillations, and so we ran a series of smoothing to try to zoom in on this pressure trace right nearby that pressure minimum. And remember that the southern one is yellow, the northern one is the orange pattern. And interestingly, you can see that the yellow one deploying inside of the courtyard of the church has a little bit less variance, it would appear, as compared to the northern one. And again, that subsonic, trying to pull up the fine scale data so that I can annotate this image here. But you want to look for those pressure whipsaws. Basically, the approach of the pressure wave will lead to some compression of the atmosphere and lead to a little bit of a pressure rise. Whereas then after that pressure pump will pass, then you get a dramatic fall in that data. And so these right here, this is a pressure fall, the compression ahead of a pressure wave, and you get a bit of a rise up there. These are the peaks up here. That's the approach of a big-time wind gust or a pressure wave, and we are zoomed way in on this data, a little bit smooth to get rid of some of those turbulent eddies here, but definitely with the yellow surginator located off to the north and the orange one off to the south. You want to look for those situations where the yellow one precedes the yellow, like right about there. That shows you compression out ahead of a pressure wave, followed by compression being experienced at the second surginator location. Sometimes they're relatively close together, very close together, oftentimes. And usually these are followed by a dramatic fall in pressure. So see this rise, followed by a dramatic pressure fall? That is definitely a pressure whipsaw, likely a fine scale structure. This is a larger scale structure showing those mesovortices within the eye rotating around. That's basically due to asymmetries inside the eye. Once Hurricane Ida stalled just off to the east, those wobbles and those mesovortices passing over the subsonic network would register as this little wave-like pattern. But you zoom in a little bit closer, it's like multiple vortices inside of a tornado, a fractal pattern here, and you can see fine scale pressure whipsaws. You can see that rise followed by a fall. Those are pressure waves associated with the big-time wind gust, and the more substantial and longer-lived ones that are experienced by both subsonic locations, those are likely approaching tornado strength. And I believe that anytime you get one of these dramatic whipsaws moving through town in Houma, it would be associated with big-time damage, with roofs getting lifted off, destruction being caused across town. You'd see sporadic areas of extreme destruction out there as well. But we did try to smooth these to remove some of that turbulence caused by just simply the wind speeds moving through the buildings there within Houma. So definitely some interesting data here recovered by the subsonic network. Eventually we'll have dozens of these subsonics deployed out ahead of a hurricane, and we'll be able to track these individual waves, pressure whipsaws, tornado-like vortices, anything that's non-turbulent and relatively long-lasting that's able to pass over multiple stations. We can then track those different tornado-like whirls, and you can even estimate the wind that is happening above the subsonic network by tracking the speed of these gravity waves across multiple subsonic sensors. And Mark did some very rough calculations, assuming an eye that was about 23 kilometers wide. He discovered that the motion of these mesoscale vortices within that oscillation happening was comparable to near roughly 150 mile per hour winds happening above Houma inside that western eye wall because of the speed of these individual gravity waves and those tornado-like mesoscale vortices passing through. So eventually the goal of the subsonic sensor is to not only determine and unravel the mysteries behind these tornado-like whirls and their structure and their fractal patterns, or whether there are repeating patterns at smaller space and time scales within these hurricanes. And is that where a majority of the wind damage is caused, is from these big-time circulations out there as well. And so our goal with the Subsonic network and the Surginator network is to provide live, real-time, high-resolution, research-grade data as these hurricanes are making landfall, and especially that live data of the storm surge that's coming in is particularly critical because that's such a life-threatening aspect of these hurricanes, that storm surge flooding. And that's our goal with the Surginator network, to provide real-time data as the storms are coming in, and maybe that data can also be life-saving. So again, here is the eye. This was my penetration of the eye. Once I realized that the storm was turning off to the north, I had to leave the subsonic network behind in Houma. The Surginator network was already streaming live data down in Cocodrie, Dulac, Dularge as well. So I went off to the northeast toward Matthews, Louisiana, and then dropped south to Lockport and intercepted that eye. And this was as I was leaving Houma. The winds weren't too bad. Eventually all these power lines came down and blocked many of the roads in and out of Houma. And but I was able to get northeast of Houma before those lines were knocked down, just as that pressure subsided to the minimum. And here you can see some of the strongest winds measured. This was just as I was coming into Matthews. Big time easterlies here on the north side of the eye, and then I went south and started to see some of that clearing, bright patches in the sky. This is about my 15th or 16th hurricane inner core penetrated, hurricane eye wall penetrated. Definitely one of the strongest hurricanes that I've intercepted. It had moved inland just a bit, so didn't get the absolute strongest winds, but this is the peak here, the eye wall coming into Lockport. Absolute mass destruction, winds likely gusting 120 to 130. in here at times, especially as those tornado-like whirls were passing by. And now I'm just going to leave you with the audio here of this eye wall. Thank you for tuning in to this breakdown of the science of Hurricane Ida, the storm surge flooding, the fine-scale pressure oscillations from southeastern Louisiana. My thoughts are with the people of Louisiana that are continuing their long recovery down there. They're still without power. Vast areas of Terrebonne Parish and off to the east, to the south of New Orleans, are still without power, and I'm hoping that power can be restored so then tap water can resume. They can get drinking water down there as well, but an absolute disaster zone in southeastern Louisiana. They could definitely use all the help that they can get in this recovery effort. Long recovery ahead, and the sad thing is that it's after the record-breaking 2020 season. Multiple hurricane landfalls as well, including Category 4 Hurricane Laura. So we're going to continue to expand this science. Thank you, Team Dominator supporters, for making this science possible. If it weren't for you, we wouldn't be deploying these subsonic sensors or surginator sensors out there. And we're going to continue to advance this science mission and collect more and more data and deploy more and more data points out there inside these storms, as we are right in the heart of hurricane season.